Morning students, from today we have to see new chapter, that is the current, electricity and magnetism. Okay, electricity is a very common thing to which we are everyday dealing. Okay, so look at our around anywhere, electric bulb is there, mobile is there, TV is there, fridge is there. Okay, so other various equipments are there in which we need this electricity. Okay, so but how this electricity is generate? Okay, that is the one part. Okay, so first of all we have to see what is the meaning of current, electricity. Okay, so up to the last lecture in chapter inside the atom we see there is one nucleus, around that what these shells are there, and in that shells electrons are revolved. Okay, as like this. Okay, electrons are revolving in that particular shell. Okay, so we see inside an atom number of proton is equal to number of electron. Okay, proton have positive charge and electron have negative charge. Okay, so what happens, both are charged particle but their number is same, that is why atom remains what, neutral. Overall charge of atom is 0 because number of positive charges and number of negative charges are equal in number. Okay, and we know proton and neutron have equal charge, only sign is opposite. Okay, so what happen in electricity, what happen only, we know electrons are present around the shell. Okay, if these electrons are moved, now in an atom these electrons are stationary now. Okay, but now this, if this electron are start to move, okay, from one side, suppose electric wire we take. Okay, this is the electric wire. Okay, suppose one electron is here and it start to move in this direction. Okay, if this motion of electron is a start, okay, then simply the flow of electron is called electricity. What? Flow of electrons. Flow of electron is simply called electricity. Okay, so what is the necessary thing to generate electricity? We know in every atom there are what, electrons. Okay, so what we have to put in motion to that electrons. Okay, then and then what happen, we can say there is a generation of electricity or electric current is a present there when these electrons are moved then. Okay, but now what happen, generally atom is electrically neutral. Okay, so in this case what happen, okay, so in case of a metals generally, okay, metals are what, metal, we see metal there are 1, 2 or 3 electrons are present in their outermost shell, we see in 5th number chapter. Okay, then non-metals, in that case we see 5, 6 or 7 electrons are present in their outermost shell. Okay, so generally what happen, it is very easy to metals to give that 3 electrons. Okay, so that 3 electron can be easily moved as compared to this 5, 6, 7. Okay, so in case of non-metals what happen, this 5, 6 or 7 electron which are present in their outermost shell, they are tightly bound with nucleus. Okay, strong nuclear attraction is there. Okay, so it is not easy to move that electron. Okay, so that is why generally electricity does not flow through these non-metals, but it very easily flow through metals. Okay, because there is 1, 2 or 3 outermost electron are present in the outermost shell of metals. Okay, So here what happen, very easily electricity flow, okay, because these electrons are called free electron, they can freely move, okay. And we know flow of electron is simply called what, current, electricity, okay. So that is why metals are good conductors of electricity and non-metals are bad conductor of electricity, okay. So just we have to remember metal are good conductor because free electrons are there. Because of this free electron, this electron can move and current, electricity is generate there, okay. So such a way generally electric current is produced inside the metals, okay. These electrons are moved from one atom to another atom to another, such a way that suppose this is a one wire, then that can move from here to here, okay. So such a way continuously electrons are in motion and generation of electricity is takes place. This flow of electron is nothing but the current, electricity, okay. It's simply called as a electric current. It's simply called as a electric current, okay. So now next topic we have to see electrostatic potential, okay. So such a consider one example of water, okay. This is a one tank of water, this is another one tank of water, this is fully filled with water, this is empty. If I made one adjustment here, okay, I join a one pipe first to second tank, okay. So what happen here, simply we know water will fall from this tank to this tank, okay, this tank to this tank, okay. This is at higher height, suppose this is our ground, so it is higher height h1 and this is present on ground, okay. So simply what happen, we know water has a tendency, it is always flow from higher height to lower height, okay. That is the first case. Then another one example of temperature, okay. Suppose this is a metal rod, okay, this is iron rod, okay. If we start to heat that iron rod here, okay, so what happen initially, this will portion get very high temperature, okay, it gains heat. Then after some time what happen, this heat temperature start to increase of this portion, okay. Then slowly what happen, this temperature of this region start to increase, okay. So such a way we can say that again heat is also flow from higher temperature to lower temperature, okay. Water is what, higher height to low height, okay. Water is flow from high height to low height. Same way flow of temperature is what, higher temperature to lower temperature. Now same case in case of electric charges, okay. We know electricity is simply what, motion of the charges, flow of charges. Now here how that charges are moved, okay. So look at these charges are moved as like one thing is important there, that is the electrical potential, okay. As water flow from higher height to lower height, as a temperature flow, heat flow from higher temperature to lower temperature, similar way charges are flow from higher electric potential to lower electric potential, Okay, these charges are also need this a difference. Okay, the difference is what? Differential difference of this potential. Okay, so that charges are always a flow from higher electric potential to lower electric potential. Okay, suppose we only take wire, and if all charges at same electric potential, okay, here whatever charges and here whatever charges, both having equal electric potential, then charges will does not flow. Okay, when it is flow, when this wire, this side is at higher potential and this side has at lower potential, then this flow of charges will take place in this direction. Okay, when if their potential of electro difference of electrostatic potential, then and then what happen, these charges will move through this wire, otherwise charges will does not move inside the wire. Okay, so this case will be happen. So we have to remember this analogy as like a water flow from higher height to lower height, temperature flow from, that is the heat flow from higher temperature to lower temperature. Similar way, there are electric charges are also flow, but they should need some difference of electric potential. Okay, then and then charges can move. If this difference of potential is not there, then that does not flow. And if difference are present there, then these charges are flow from higher potential towards lower electrostatic potential. Okay, so that thing here we have to bear in mind. Okay, so up to the last point we are study electrostatic potential. Okay, if somewhat difference of potential is there, we consider two tank example. One is at higher height, one is at lower height. Another one example of temperature, one is at higher temperature, one end of wire is lower temperature. Okay, so what happened, this difference of height is there. Okay, difference of height is there in between these two tanks, somewhat difference of height is there. Okay, then temperature example we see, higher temperature and lower temperature, so somewhat difference of temperature is there in between these two ends. Okay, so this difference of height is called height difference, this is called temperature difference. Such a way we consider electric wire and we see one case, if electrostatic potential difference is there, then and then charges will flow, otherwise charges does not flow. Okay, suppose this is at higher electrostatic potential and this is at lower electrostatic potential. Okay, higher electrostatic potential and lower electrostatic potential. Okay, so whatever the difference between potentials in between 2 points, what difference of potential between these 2 points is simply called as potential difference. Okay, difference between electrostatic potential between 2 points is simply called as a potential difference. Okay, whatever the one is at higher and one is at lower. So somewhat difference of potential between them, that difference is simply called as a potential difference. Okay, we know for the motion of charges we still require potential difference. If potential difference is not there, then the charges cannot be moved. Okay, this is a very basic condition. Okay, to how we can generate potential difference. Okay, we know we uses different type of cell in remote, in watch. Okay, if we remove that cell, then that somewhat electric gadget does not work. Because of what? Cell do what? Cell generate this potential difference. And if this potential difference is absent, then charges does not flow. Okay, so we will be see later what is the importance of cell in different types of cell, how electricity is generated there, how charges are flow inside the cell, that we will see in later part. But one thing we have to remember, without potential difference electric charges does not flow. Okay, now next topic we have to see, that is unit of electric current. Okay, we know electric current is simply what? The flow of charges. Okay, is simply called as a electric current. And always remember, ampere is a unit of electric current. What? Ampere. Okay, it is denoted in short capital A. Okay, ampere is a unit of electric current. Okay, now such a way, if in 1 second, okay, suppose whatever the charges are passing through an wire. Okay, suppose electric current is passing through this wire. Okay, now we consider time of 1 second. Okay, then whatever the charges passes through, we know motion of electron is nothing but the what? Electric current. And electron is what? Negatively charged particle. So simply what? Charges are moved, negative charges are moved from this point to this point. So whatever the charges are passes from this wire in 1 second, that is called unit electricity. Unit electricity. Okay, so 1 ampere is nothing but the what? Charge. Charge has a unit coulomb. Charge has a unit coulomb per second. Coulomb per second. Okay, charge has a unit coulomb, that is write as a C, and time has a unit what? Second, which is denoted by letter S. Okay, coulomb per second. Okay, whatever the charges are passed through wire in 1 second, that is nothing but the 1 ampere electric current. 1 ampere electric current, that are 1 coulomb per 1 second. Okay, 1 coulomb per 1 second. Okay, now next topic we have to see, that are the electric cell. Okay, so we see application of electric cell in various equipment. Okay, if wristwatch is there, then there is also a one cell. If remote is there, then there is a present also a cell. If solar is in our home, okay, then what happen? That solar also generate electricity. Okay, so that are all are what? Simply cells. Then how that electric cells are important, that we have to see. Okay, first thing we see, that is the potential difference. Okay, we suppose this is a one wire. Okay, this is a one wire as like this. Okay, this wire is disconnected from here. Okay, now electric current is flowing through this wire or not, because this is the only wire. Okay, so we know very basic thing is that potential difference should be present there, then and then charges can flow, and that we call electric current. But here what happened, nothing we connect to, we not connect any cell, we not connect it into electric circuit. So this all wire is at one electric potential. Okay, and everywhere electric potential is the same. Okay, so what is the importance of cell? Look at, this is the sign of cell. Okay, positive, negative. This big line indicates higher potential, and this small line indicate lower potential. Okay, now what happen, as we connect this cell here, then what happen, electricity can flow now through this wire. Okay, but before connect this cell, electricity does not flow. Okay, so actually what is the important role of that cell is here. Okay, as we connect this positive and negative end to these two ends of wire, then what happen, this end become higher electric potential, this end become lower electric potential. And we know if higher and lower, the difference is a present, then and then what happen, electric charges can flow. Okay, so this cell do what, cell, electric cell, what it generate potential difference between 2 points of conductor. Okay, it do what, it generate potential difference between 2 points of electric conductor. So what, as the electric potential is generated, then what happen, electric charges can be easily flow through this conductor, okay, so that is the actually importance of this electric cell, what, to generate electric potential. And we know if electric potential is there, then and then current can flow. If we remove this cell, okay, then what happen, as like this, only this wire, then what happen, current does not flow in this case, because the cell is absent here. As we connect cell, current is start to flow. Okay, so that is the importance of this cell. It generate electric potential difference between these 2 points of conductor. And if cell is not connected in this case, so electricity does not flow. Cell is connected, electricity is flow. Look at, if you remove one cell of remote, then again what happen, we cannot change channel of TV. So what happens, simply electricity does not flow inside that remote. Okay, so you have to remember only importance of cell to generate potential difference. Okay, that is okay for today. From tomorrow we have to see different types of cells. Okay, dry cells is there, chemical cells is there. Okay, so generally we have to see their diagrams and construction. Okay, so remaining part we will see in tomorrow's lecture. Thank you.